Good morning, ladies and gentlemen. Thank you very much for joining this webinar. Moving on, HSA will be purely two ways of managing HSA. One is the command line interface, which is very technical. And for mass deployment, we'll be having our SD-WAN Orchestrator. So we'll talk about SD-WAN Orchestrator 2 to 3 weeks time. Orchestrator is the easiest part. So we want you to understand the hard part first, because it's still very important to understand the fundamentals. Initially, we had our prototype a few years ago, which was HSA 100. So that was mostly used in Singapore market, and it was quite successful. We did that pilot launch. We sold a few thousand in Singapore. Then in early 2018, we launched HSA 500 series. So that was initially driven by many requirements in Indonesia for the banks, and especially with the SIM card for M2M purpose as an alternative for the satellite to connect ATM back to the data center. Then, of course, we also evolve and develop, so you become SD-WAN capable, multi-WAN link balancing, VPN, and dynamic routing, and all that. Over the last 2 years, it has evolved and grown dramatically, so it become a very powerful all-in-one box. The hardware itself is built to be very high-end for SME or for outlet type of size of deployment, but the hardware itself is a very rock-solid hardware from using Qualcomm chipset. Although we call it 500 meg throughput or HSA 500, the actual throughput you can go more than 700 megabit per second throughput. The LAN ports or WAN ports are gigabit Ethernet, and you can use any of the port as WAN port as well. It also comes with dual SIM card support. So that means within the box have two LTE module. For the L2 model, we have customized our own daughter card to attach to the Qualcomm main board so that we can slot in the LTE module. Customer just need to plug in the SIM card natively. So we don't need to use any USB dongle, which is very hard and unreliable after you use it for a while. One of the early vendor to launch hardware that supposed to natively support dual SIM. So in those days, a lot of the other vendors were still using USB dongle to support 4G. And very soon we'll be supporting 5G as well. So we are pretty advanced in this mobile SD-WAN space. Then we have the SIM hardware, which comes with onboard Wi-Fi dual band AC. It's very high performance as well. Good coverage, and theoretically you can support more than 100 users, but we will try to recommend customer not to use so much because ultimately it's SoC board used for branches and retail shops or F&B shops. Practically up to 100 users, it's okay, it's fine, it's been tested. Some of the feature highlights, you can connect to fiber, internet, MPLS, Ethernet, LTE, or PPPoE. So on the LAN side, you can have multi-VLAN, which we'll talk about it later with Wi-Fi. And we can also do link balancing between ISP links. And we can also support dynamic routing, policy-based routing, and redundancy using VRRP. So all these are enterprise-grade features which are inside our box as well. We can prioritize different applications, guarantee bandwidth for critical applications, or limit not so critical applications. Then you can run different VPN protocols that are all supported. And especially using our SSL VPN, we can very easily provision multi-tunnels to support different WAN connections. Then you can do different ways of VPN bonding. You can use layer 2 bonding, or you can use our multi-link balancing feature to do VPN load balancing as well. Those are some of the more advanced features. Then we also have, which 2 weeks later, we'll talk about SD-WAN Orchestrator to provision thousands and thousands of boxes and VPNs and tunnels, dynamic routing within just a few clicks. So the efficiency and speed to deploy is massive. The use case for HSA has been used in banks, especially ATM. Then service provider, you can also use it as a cost-effective SD-WAN solution for some of the retail or F&B chains. And also it has been used in Wi-Fi on the go in the bus to use mobile internet backhaul and deliver Wi-Fi within the bus. Dive into a little bit more technical details. Although it's a SOHO or it's a remote branch router, it's still a high performance router. High throughput. We support all the advanced networking protocols, IPv4, v6, NetFlow, SNMP, and you can send syslogs for audit trail. You You can track firewall access logs to export it to external syslog collector. So all the WAN or routing or layer 2 or layer 3 various routing protocols can do bridging, bridge multiple ports, or can do VLAN tagging and multiple SSID. And also, especially it supports the dynamic routings and policy-based routing. So most of the common networking protocols or features that you can think of is available in this tiny box. Although it's tiny, or rather it's cost-effective, but all the enterprise-grade features are available here. And security feature, it has built-in stateful firewall, so it can be a good parameter firewall. Most of the time, even a lot of customers purchase so-called UTM firewall, because today a lot of the enterprises, especially SME, the internet access is largely outbound. So all you really need is just a stateful firewall. Stateful firewall means you basically provide outbound access and you block anything that comes inbound. That means you block anything that come in. So being stateful means you go out and the firewall automatically allow the return traffic only. And anything initiated from outside will be blocked. So that's basically all you need for most of the SME networks. But some customers do require some advanced features like URL filtering, category-based, don't want the employees to go to certain categories of website. We have actually done integration with Menlo Security. So Menlo Security is a Gartner-listed web security provider. So they do web isolation. You can also do URL filtering or content filtering. So web isolation basically, it sits in between the user connection and the destination server or the content server. But it's unlike proxy. Proxy basically scans the contents to detect any attacks or a virus or harmful content. But the web isolation, basically, when the user sends a request, the isolation platform sends on behalf of the user, sends a request to the server. So when the server returns the content doesn't really return to the user directly, unlike proxy or some sandbox scanner. So the isolation is, the content stops in the isolation platform. What he does is he will only render the content using HTML5 to regenerate the content to the user without any potential harmful scripts included. So that provides a like day zero kind of security protection for web browsing. So we have done the integration. We have some special development with Menlo, and we have developed that. We have already deployed in some of the government agencies in Singapore and I think in Indonesia as well. So the safe DNS integration is more of a URL filtering. So based on DNS query, we will look at the query belongs to which category to determine this should be allowed or not allowed. So it's a much more cost-effective and much simpler integration, but it serves the purpose for majority of the requirement. So as a firewall, yes, it does natively provides layer 4 up to layer 4 protection, and with our partner integration up to layer 7. So it's a complete suite of security protection. We have a separate webinar to talk about this later for the layer 7 content security with our ecosystem partner. Then the other firewall which are commonly used like address translation, source-based or destination-based or port forwarding, all these are all readily available, and these are very, very easy to configure for us, and which we'll discuss that later. And VPN protocols, all the common VPN standard IPsec and GRE, commonly deployed and supported as well. SSL VPN. SD-WAN essentially is a VPN overlay with all the other advanced technologies. So our VPN overlay for the SD-WAN is using SSL VPN. So it's unlike most other vendor use IPsec. So the beauty of the SSL VPN is it provides much lighter overhead, and also in terms of compatibility across different networks, it's easier. Also, it's very easy for us to provision. Then we have all the bandwidth control, QoS, supports different type of application or network or IP-based control, or once you turn on Wi-Fi hotspot, it supports per user-based QoS as well. And of course, we have been very strong in the Wi-Fi captive portal. So HSA supports our captive portal features by integrating with HSG or Cloud HSG. So you can point to our Cloud HSG, all the Wi-Fi hotspot features are available, captive portal, user control, Wi-Fi marketing is all available. So as an end-to-end solution in such a tiny or cost-effective box, having all these advanced features, Wi-Fi hotspot features, security features is really a huge value to our end customers. There are different models that we offer. So the most base model basically is just the Wi-Fi only. So it doesn't have the LTE. So you can use it as a Wi-Fi hotspot router, or you can use SD-WAN router. So you can just use as a simple SME router because the performance is really good, and you can use it to do link balancing as well. In many other countries where the ISPs are not reliable, traditionally customers would need to buy dedicated link balancer for that purpose. So now you can just use HSA as a very cost-effective link balancer, or as a router with a link balancer feature. L1 provides a single SIM card support, and L2 has 2 SIM card support. So you can do a lot more stuff. You can do a VPN load balancing or VPN bonding. You can do HA, or you can do dual SIM for failover between 2 mobile service provider. With all these features and capabilities put in together, now HSA is part of our SD-WAN solution. So you can use it as a SD-WAN remote. Then we have the gateway, which is our CMG. It can be a VM or it can be a hardware. You can support different connections, PPPoE, or 3G, 4G, or 5G later, broadband or MPLS. Then we will have that orchestrator massively provision all the routing or the VPN tunneling automatically by business policy, rather than manually have to configure all the metrics or importing all the VPN profiles, which will help you to reduce a lot of your effort later. Having the experience of doing it manually today is still good, so that you understand the fundamentals. But once the orchestrator comes out, most of the time you'll be using the orchestrator to provision or the deployments. On top of being an SD-WAN router, you can use as a converged solution as a SD-WAN and hotspot, especially for retail or F&B outlets, where you want to use as a SD-WAN for VPN connecting to your data center for secure transaction. You can also broadcast guest Wi-Fi or staff Wi-Fi for your internal devices. Because it comes with the Wi-Fi, you can provision VLANs for different SSID, and you have different LAN-based connections to plug into the LAN port. And also, you can optionally have the LTE as backup or bonding on the WAN connection. So it's a very flexible device, and yet it provides all the features, especially for retail F&Bs, and also for any business that has many outlets or branches. And it has also been very commonly used as a Wi-Fi hotspot router. So basically integrates with our cloud HSC, or HSC can be in customer data center or as a VM in the cloud. Then the HSA will point to the HSG for portal and authentication, user access control. Then behind the HSA, you can optionally put 1 or 2 AP to extend the Wi-Fi coverage in case it's a bigger physical area. So again, all of them can be provisioned by Enfusion, and the portal will be centrally managed on HSG, and user management, everything will be on the HSC. So the HSA will be just a one-time deployment, and in fact, it's a zero-touch deployment. Once you plug in the device onto the internet with a dynamic IP address, you will automatically call home to Enfusion, where you can remotely push down a template of configuration. Then all you need to, in terms of deployment, is just to have someone physically plug in the hardware and have a one-time provisioning of the configuration template and push down to all the devices automatically. And the rest will be just the Enfusion will provide you the monitoring and ongoing alert and reporting. You don't really need to touch any of the box after that. The other case is to use as a mobile internet, to put it on the vehicles to connect to the internet using mobile network. Then you can have that Wi-Fi broadcast within the bus. Again, you can provide, because of the captive portal feature, you can do Wi-Fi monetization as well, Wi-Fi marketing. Okay, I pretty much briefly covered on the sales part of it. I know you are expected to see things in action. You want to see all the detailed stuff. So I will start to proceed to the hard part. It looks hard, but as an engineer myself, I like it because command line is something that once you get used to it, it's actually very efficient and very fast. And most importantly, it helps you to understand the fundamentals. So we will go through the hard part today, then we will talk about the easy part later, okay, with the SD-WAN Orchestrator. So we use this topology to do the lab. So basically we have the WAN, and I have a SIM card put in the box. Let me just show you the actual hardware. So I basically have this L2 on my table, and these are the 4G antenna, and these are the Wi-Fi antenna. So this is a LAN port that connects to my PC. So I'm just going to have my PC connect to this static. Then the console also connecting to my PC as well. Then I have already slotted in a SIM card. Just for information, the SIM card the metal has to face upward, the small little card face outside. So I will just put it out and show you how to put in again. Okay, just make sure your SIM card is slotted in this way. This way. The biggest problem that we have so far, the SIM card is not properly correctly slot into the slot. Okay, so I just show you how to slot in. I'm not going to slot in now because I will just use one SIM card for today. The antenna and everything is there, so make sure the antenna is also very tightly connected, because again, without the antenna, there will be no 4G signal. The 4G interface cannot come up, and the Wi-Fi signal is very weak. So the antennas are very, very important. These are the settings for the serial console. By default, you can connect to one of the LAN ports to SSH, because you automatically gives you IP address over DHCP. Then you can SSH. You can also have the console. Be careful with the baud rate for HSA and CMG. They are different. HSA is 115200 and CMG is 19200. Okay, so everything else is the same. You just use the normal Cisco type of a console cable. And for default login, you're already familiar. And for the first time when you use this, because there's a huge change for the previous version and the current version, which are purely command line supported, you will need to upgrade it, and you will need to do a write erase and reboot. Okay, then you will have a default config boot up. Just bear in mind, whatever you configure on the UI will be lost. Okay. So if you are not comfortable with your existing deployment, which you already have it with the UI, my advice is future ongoing support, you probably convert it to command line, but it's just bear in mind the conversion, you need to do a write erase and reboot, then you put in the new command line configuration. Once you upgrade to the newer version, whatever you configure on the UI will be lost. So they have to be transferred to command line. I basically have ready console to the box, so I will run an upgrade. All you have to do is just connect the LAN port by default to DHCP network. Connect this LAN port to your DHCP network. Normally, most of the ISP is DHCP or your office. Then you have internet. Then you will just upgrade it to the latest stable release. Write erase. Once you do a write erase, you will reset to the default config. At the moment, after you've done the write erase, if you do a show startup, that's basically the default config. So you just reboot, you load the startup config. So that's the preparation work. And before we do the actual configuration, I would like to introduce a bit of command line interface. I know many of you are already very familiar, but because of the different focus of your, or rather different area of your work, some of you might not be familiar, or maybe don't use that often. So I'll just share with you some of the experience of some command line shortcut, because once you get used to the shortcuts using the command line interface, it's very, very powerful and it's very efficient. And actually this shortcuts applies to some Linux-based configuration or Linux commands. They are pretty much the same shortcuts in the command line. Let me see whether, okay, it's up. Okay, because the console has a lot of text coming out, and which is not very easy for me to do the demo, I will SSH in instead, which will be pretty much the same. I need to wait for the firewall to activate. Okay, so this is basically the command interface. You go into the enable mode, then you can go to the config mode. You can do show run when you are on the config mode, or end. You can enable mode, you just do a normal show run. Question mark to say what are the available commands. Similarly, you don't have to type the whole word. You can just type part of the word, then you can tab to see what's the next available full words that available starting with C, for example. Then if you want to configure interface, again, you don't need to type the whole interface, which is a lot of typing, but you can just tab and question mark to see what's the next available options for you to proceed, whether you're configuring VLAN interface or a normal interface. Let's say I'm going to configure a firewall. You just type firewall tab, or question mark to see the available commands, full commands available, and each one comes with description. So let's say I'm going to permit more source to SSH into the device. You just permit log. So basically permit log will do the login for every connection so that you can do audit trail. You send the logs to external syslog collector because input can only be inbound. It means you are trying to access a service to the box itself. Or you can come in from all other interface. Let's say from all other interface and source. Let's say, okay, if you're not sure after the source, what is the format, you can just follow the same format. You can just TCP, let's say 22. Okay, so that basically adds the commands. You can verify this because I didn't put the sequence very well. Normally you'll put the TCP on top, in front of here, in front of the source, or after the interface. So I got a little bit warning, but it's okay. All I want to show you is how to play around with the shortcut right now. So let's say if you want to change, let's say 11, another rule. So you can use the arrow key. You move all the way to the front, which is quite slow. But instead, you can actually use Control A. So straight away you move front. Let's say you change from here, or you want to change some other words, let's say, then you Control U, or anything starting from here, you will remove, okay? So that gives you very handy, or you want to, for example, change this whole thing. I want to change to 192, Control W. So that gives you, so you don't have the backspace to type the whole words to remove it. And similarly, you move to the front, or you want to move all the way to the end, Control E, so that you want 80 because you just want to change the port number. Or you want to remove the whole thing, you can either Control C, or you can just Control U again, just to erase the whole line. Try to follow the shortcut to practice this keys. It's very, very useful, especially if you are a very hardcore network engineer. And by the way, Cisco commands have the same shortcut keys as well. So once you master this, it's applicable into a lot of areas, whether it's Linux commands, Cisco, or many other vendors use similar shortcut keys. So it will be very helpful for you. Before we move on to do the actual configuration, it's very important to understand the HSA internal architecture. So if you're familiar with the CMG or HSG, we have several ports. The low end, we already have 4 ports. Each port is actually router port. It's a layer 3 ports by default. So the router port means you will do routing. But in HSA, there's really just 2 router ports on board by default. One is the ETH0. Another is ETH1. ETH0 is actually the WAN port, which is the one that connects to the internet by default. You can use the LAN port for internet too. By default, this port labeled as WAN, so it's ETH0 on the internal architecture. So ETH1 basically connects to all the LAN ports. It's actually a router port for all the physical LAN ports. This LAN ports, by default, they are switch ports. So the switch ports, the default gateway, or rather they are using ETH1 as the router port to route traffic to the next segment, which is to the WAN, and go out to the internet. The HSA essentially is a combination of router and switch. On the backplane is a router, and the physical port is actually a layer of switch. By default, these are the switch ports. Okay, 1, 2, 3, 4. And they're using ETH1 as a router port to go out. The switch ports, there's always a concept of VLAN. So by default, they are all in default VLAN 1. And ETH1 is essentially the router port for VLAN 1. So it's like a VLAN 1 interface for them to route, to take the traffic to the next level, to the routing firewall and all other advanced feature, and before the traffic goes out. Okay, so that's the default architecture. Then there's 2 radio, the Wi-Fi radio. So one is the N radio and another is the AC radio. So N radio in our configuration, we call it Wi-Fi 0 or Wi-Fi 1. Okay, but in the hardware level, there's ATH0 and ATH1. Okay, ETH1 and ETH0 is Ethernet. Ethernet 0. So essentially, there are 2 Ethernet ports, a routing Ethernet port. The ATH is a series of wireless chipset. So it's ATH, which is basically is the Wi-Fi antenna. So the Wi-Fi antenna itself cannot route traffic out. Okay, Wi-Fi is really a layer 2 technology. So you will have to attach to a VLAN. So you can attach the default VLAN. So by default, when you configure any SSID, they are attached to VLAN 1, so which will rely on TH1 to go out. Or you can create VLAN for different SSID, so you can attach them to different VLAN, which we'll talk about it later. Just trying to go as fundamental as possible. I know some of you are already very familiar. So in any case, it's also good to refresh the fundamentals. Then once you have a LTE connected, you will create the LTE interface. Okay, these are also layer 3 interface. The traffic can go out directly, routing interface. This rule is added. Once I have write erase reboot, then you will basically have this default config, which is what we see here as well. So what this default config says is the ETH0 use DHCP to connect us. We're expecting a DHCP from the ISP. If it is a static, you'll configure a static IP just like this. Whatever IP with a prefix, subnet mask prefix, and you'll have to add a default gateway. Because if it is static, you have to add a default gateway. If it's DHCP, you can learn DHCP from the ISP. And if you don't want to learn the default gateway, there's an option for you as a no default. That means you don't want to learn the default from the DHCP gateway. There can be reasons for you not to learn default gateway. For example, maybe you have multiple connections. Each one give you a connection, give you a default gateway. So you probably find it's hard to manipulate the traffic, especially if you want to do policy-based routing. So you will not to use the default gateway from the ISP so that you can configure your own routes or policy routes later. Like Malaysia, where you have PPPoE on VLAN 500, so all you have to do is you configure VLAN, interface VLAN, and this is essentially the Ethernet interface ID. So on the command line, if you do interface VLAN, you question mark, there's really just two choice, whether it's ETH0 or ETH1. Because this is for internet, you'll put ETH0 and 500. Then you will use the PPPoE command, username and password, and you will basically automatically dial the connection for you. Then you will have the LAN interface with the IP address, and you enable DHCP server for this interface. Once you put in this command, they will automatically generate this set of options. You will learn the default gateway that you need to broadcast the user to be your interface IP address and the range. You can manually change this by yourself. So for example, okay, you enter and you can see the available commands for DHCP. You can do static mapping, for example, map the device MAC address to IP address instead of dynamically give them IP. You can set this DHCP options for some like VoIP phones or some wireless controllers. Most of the time, you just say the router commands, this default gateway, which by default is there. You can change again, and DNS server that you want to broadcast to the user, and also range. So most of the time you will really just use this tree. Okay, you can change this, the value. The name server we familiar, and the input rule basically default allows SSH from this range of source IP, which is from the LAN side. So it means you can SSH into the box from the LAN side, not from the WAN side anymore. The access, we will explain a bit more on this later, is for the traffic to go pass through the box. So that means anything goes out from the WAN, you'll be permitted. And similarly, the SNAT, source NAT is anything exit from this interface. ETH0, you will be masquerade. The source IP will be changed to the IP of this interface. Okay, so there's a lot of other commands you can use to verify. Whenever you change something or configure something, it's always important to use the shield commands to verify the actual working status is the same as what you configure. Okay, ideal situation is always whatever you configure, you work as it is, but you can make human mistakes or things can go wrong. There's a lot of reason for things to go wrong. So there's always a good idea to use the shield commands to verify the exact working status after each of the commands being configured. For example, you want to shield interface, shields all the layer 2 interface. Okay, it doesn't have the IP address. And shield IP interface, it shows all the layer 3 interface that has IP address attached to it. So ETH0, for example, we're getting DHCP for ETH0, and ETH1 is this IP that we configure. And you notice that the interface name has a BR in front of it because we enable bridge mode for this interface. So automatically on the layer 3 interface become a bridge interface for ETH1. The reason why we default enable as bridge mode again is because later on, most of the time we will have Wi-Fi, and when Wi-Fi attached to VLAN or physical interface, the interface has to be in bridge mode so that you can bridge the Wi-Fi to the LAN. Okay, so there are some other very interesting commands like show DHCP server to verify your configure DHCP range is enabled on ETH1 and range that you set, and lease time, default 24-hour. And if you really have device connected to it, you can do a show DHCP list. Then you will see that IP address being given to different devices and with different MAC address, which we'll review this later on. Okay, so the firewall rules as well, you can actually verify the input rule, which is basically the rule that permits access to the device itself. The most powerful weapon in a Swiss knife for any network engineer is TCP dump. Okay, this one. TCP dump basically gives you all the visibility on the packets. When you have a case, for example, the user say, oh, I cannot access the internet. So where do you start? There's a lot of ways you can, okay, you do pin trace route, you just cannot go through, you don't know whether it's an ISP issue or it's an internal rule configuration issue or is the device issue. By understanding the topology, you will know when someone wants to go out to the internet here, the first thing he has to do is his request has to hit ETH1 on the LAN side. So you just TCP dump on the ETH1. So for example, or BR1. Okay, VRRP is the layer 3 interface. So if you have a request coming in, you can do a lot of filtering. In case it's in a live network, there's a lot of traffic. You can filter by port or by IP address. So you filter the source, let's say. So you can see the traffic does come in, but you don't see the traffic going out. Okay, so what you do is you will basically dump on the LAN, on the WAN interface. If you don't see his request come in, there can only be two reasons. One is he's probably never connected to the network. Two is maybe he gets a wrong default gateway so that his request doesn't come to me, it goes to somebody else. So you can do a like show DHCP list to see whether are you giving an IP address to him, or on the device just show IP config to see the default gateway. So if it does come to you, but it doesn't go out of the ETH0, then it's likely your firewall rules that is blocking. Then you check your firewall rules. Okay, so the firewall rules permits anything that goes out. Okay, that's good. But maybe the ETH0 has the traffic, goes out, but there's no reply come back. So it could be because you don't have that SourceNet rule. That means you are not hiding your source IP. When your request go out, it's a private IP and the other side doesn't know how to return to you. Then you check your SourceNet rule to make sure it's been overloaded or masqueraded to that interface IP. Okay. So, and also your TCP dump, you will be able to see the source as well anyway. And if there's no reply come back, so it's most likely the other end doesn't have a route back to your source IP. It talks like quite a bit of effort to talk about it, but once you're used to it, within a few minutes, you will quickly identify the root cause already. Okay, at least you will isolate to which area that can cause a problem to you. Then you can focus on that area. This is nothing to do with our HSA. It's a generic network troubleshooting process. But the HSA gives you that tool, especially the TCP or the show the visibility tools to allow you to give you the visibility so that you can troubleshoot easy. Imagine on a Cisco router, if you want to debug IP packet, you have to configure how many rules to make that happen. And it's very hard to get that statistics out for that dump. And here is real time, the TCP dump. First question is, not yet. It will be soon. Okay, we will launch the HSA 500 with 5G module probably in July, early July. So it will be just in a few weeks time. We're doing the final prototyping finishing. If you're using one SIM, you will just put 2 antenna for one SIM. So there are 4 antenna for 2 SIM. So each SIM card takes 2 antenna. So if you have one antenna for one SIM card, you will still have a signal, but it's not fully optimized. So that's what we say. We would highly suggest you to put all the antenna, at least if it is one SIM, put 2 antenna. Write erase, can we restore configuration? Yes, if you write erase the box, come up with a default config, there are a few ways you can restore. You can still go through the traditional way, go to the UI to restore the config, but just bear in mind whatever in the command line will be restored. Whatever you configure on the UI will not be restored. But you can use that UI to, for example, you can actually use legacy mode. Okay, this is only for legacy mode. In future, this UI will be disabled. There will be no such UI. You can still restore a backup, but you will still see the whole backup file. But when you restore, whatever takes effect is only when you do a backup now. So when you restore, whatever that is configured in here will be used. But there's still a catch right now before the orchestrator kicks in. Let's say you're on the standalone device. If you have VPN profile, you will still use this option to do backup and restore because the command line doesn't capture the VPN profile. But if you use this option to do the backup and restore, it restores the VPN profile as well. So this is one way to restore. Another way is certainly to push from mFusion, right? You can restore from mFusion, or you can just go to the command line, to paste your configuration. Change the IP on the LAN interface. Okay, if you look at this new version at the default config, there's no VRLAN anymore. Okay, essentially the VRLAN is, like I say, is the ETH1, okay? But so this VRETH1, okay? If you go to the UI, I mean, just to refresh your memory. So there's ETH1 and ETH0. So these are the traditional VRLAN, okay? So this is VRETH1. And if you want to change config, you will change from here. You will change from ETH1. You will just remove this. Then you add in your new IP address. Okay, just like a CMG, it will be very much similar to CMG. Actually, most of the syntax are the same. Okay, when you do write erase, you will erase your current config. And after you reboot, you will only have your default config. So like I say, if you currently have configured in UI, you will have to reconfigure it under the command line. It's not a lot of work. There are some outdoor antenna, yes. We have some projects here in the shipping yard. The shipyard is very massive. The place is very big, outdoor. So we have ordered the outdoor antenna and it's been tested and it's pretty good. GPS, yes, it's still same. The write erase is highly recommended because anyway, if you don't use the write erase, it's also okay. It's just that when you reboot, after you upgrade to the latest version, when you reboot, the config on your UI will be gone anyway. So your config on existing config on the command line will remain. So you have to reconfigure the UI part. Whatever was on the UI to configure on the command line, for example, interface IP address, which you use to configure on the UI. But the routing command that you have on the command line will retain. So the write erase is just to give you a fresh start. Probably you're not familiar with the syntax, you don't know where to start. So that gives you some sample, like how to configure interface. But it's not necessary to do write erase. But if you don't have any existing command line config on your current box and everything's on the UI, after you upgrade and you reboot, there's nothing in there. So the write erase is just basically to give you some default setting, especially if there's a box deployed in the remote end. If you don't do the write erase, and if all the config was on the interface configure or was on the UI, if you reboot, the box will become inaccessible. You can't even reach from mFusion. So here, if you do a write erase, at least he will call back to mFusion. You can carry on your configuration from mFusion, which we can briefly talk about it later. Okay, so we will go on to talk about configuration. So the first thing, after seeing the default config, the first thing, okay, is the base config is like, sometimes you may want to assign different ports, although there's only 4 ports, different port into different VLAN. In order for the traffic in this port to go out, you have to have a VLAN route through a VLAN, but you don't want it to be part of the default VLAN, so you have to configure a new VLAN. This VLAN essentially is attached to the main interface, ETH1. So it becomes a subset of the interface. So all you need to do is basically configure interface VLAN 1 as main interface name and VLAN number, and that's it. Automatically, a VLAN is created under ETH1. So we will do this together. Okay. So interface VLAN 1. So let's say, assuming I'm going to have first port to be under VLAN 10. So before that, we want to create the layer 3 interface for VLAN 10. Okay, so that traffic in this VLAN can route out. You can optionally bridge or you don't bridge, because bridge is only necessary again when you want to bridge with Wi-Fi. If you don't need to bridge with Wi-Fi, you don't need to do that. But for now, I need to do, because for the next lab, I'm going to bridge this with VLAN 10. So the description, I can just copy the description. And our bridge. Okay, so we're basically converting VLAN 10 into bridge mode and enable. So IP address. So you will add an IP address to VLAN 10. So I will show IP interface. Sorry, show IP interface. So you actually see VLAN 10 is created because I bridged it. That's why when I show IP interface here, I don't see anything. By default, when I show IP interface, it's trying to show VLAN 10 IP address. But the IP address is not attached to VLAN 10. It's attached to BR VLAN 10 because I enable this to be a bridge mode. But the VLAN 10 is still there as a layer 2 interface. If you show interface, VLAN 10 is there, but that's a layer 2 VLAN. So the layer 3 is the bridge interface. And also you do a show interface VLAN, you will actually see VLAN 10 and it's attached to ETH1. So we have created a layer 3 interface for VLAN 10. Again, whenever you configure something, it's highly recommended to configure, to use the show command to verify. Okay, so now I'm going to configure DHCP for VLAN 10. Whoever attached to VLAN 10, let's say connect to port 1, which I will assign port 1 to VLAN 10, you will get IP address from me. First time when you enter DHCP, you will automatically learn pre-populate DHCP setting for you. So there's a pre-populated. You can change, if you want to change, you can change to some other DNS IP or router IP or range. Okay, all this you can change. Then you start your DHCP service for this pool. Okay, as you can see, it's a little bit lag because I'm using SSH. When you restart, there's a reset of the network service, so that causes my DHCP to have some lagging. But if I do it from console, you'll see the lagging is much lesser. But the problem is console gives me too much message, and which is not very good for demo. So now if I show DHCP, then you will see the new scope for VLAN 10 is there. Show IP interface. BR VLAN 10 is there, and show IP route. It automatically creates a connected route for VLAN 10 as well. So I'm going to assign VLAN port 1 into VLAN 10. So now we are configure the switch port, the layer 2 port. Okay, physically there's only 4 ports. If you question mark, there's really just 4 ports. You question mark, there's only 3 options: enable, disable, or assign to VLAN. When you VLAN, you question mark, you have 2 options. You can assign to an access port, or you can assign this as a trunk port. If you use the 1Q, which is trunking, you can attach multiple VLAN to this port. But if you say access, you will set this port to be an access port and you assign to VLAN 10. So it's very simple. Imagine if you do it on a Cisco router, you have to switch port mode access, switch mode trunking, and switch access port. So there's so many commands. For us, it's just one. Okay, you set and you show switch. There is a VLAN 10. Okay, I haven't enabled yet. Sorry, let me enable it. When you show switch, this is looking at a switch level. Okay, when you show IP, you are looking at a layer 3 level. Okay, so IP is talking about layer 3 interface. So switch, this shows the mapping of the switch interface. That means VLAN 10 is mapped to, this is VLAN ID, mapped to port, assigned to port 1. Before I do this, if you look at the area one, before I do the enable, 1, 2, 3, 4 is all on VLAN 1. Okay, but all the VLAN default is tagged to 0. 0 represents CPU. So VLAN 2 is for the WAN port. Okay, so the port 5 is actually the WAN port. So again, then show VLAN, show switch port to show the VLAN mapping to the physical port is important. In the previous slides, we talked about assigning a port to a VLAN. So basically make this port as an access. By default, all the port is an access port, and all the ports are in VLAN 1. So now we want to assign this port to be in a different VLAN so that the users connected to this port cannot communicate with the devices on the other ports. So you want to segment them into different network. So the syntax to configure this is very simple. First of all, we define the VLAN 10 layer 3 interface so that the traffic can route. This is a layer 3 interface for VLAN 10. Then we assign this switch port to VLAN 10, okay, into access VLAN 10, so that separated from the rest of the network. Then trunking basically allows you to pass VLAN tagging to that switch port. Okay, So that means you can accept frames belonging to different VLANs to pass through this switch port. So we will allow VLAN 21 and 22 to pass through. So the tagging basically is a standard protocol using L2.1Q. So we will have, let's say, in this example, VLAN 21, 22. So we will have still configure the layer 3 interface. We don't have to bridge now. So we just configure normal interface, switch interface, VLAN interface. And we will use this syntax instead of access. We will say .1Q. That means we will encapsulate the frames. When it comes in, we will recognize them, allow 21 and 22 to come in. Okay, the switch side will encapsulate frames belonging to different VLAN. So that means whatever downlink here has to support .1Q encapsulation, whether it's an AP or it's a switch. When the frame comes to us, we will accept the VLAN tagging for 21 and 22 and pass on to upper layer 3 interface for routing. Okay, so the same concept goes for any other switch or Cisco switch or routers. Okay, the router, most of the router doesn't have the switch function. Okay, so there will be just purely layer 3 interface VLAN. So I have configured for VLAN 2, port 2 to belong to VLAN 21 and 22 to accept VLAN tagging for 21 and 22. So similarly, we have configured VLAN layer 3 VLAN interface and 21 and 22 as a sub interface of ETH1. And we have IP address. So you verify the IP address and VLAN 21 and 22. And this time we are not doing bridging because again, you will only need bridging when you want to bridge with Wi-Fi. Okay, like ETH1, I want to bridge with Wi-Fi. VLAN 10, I want to bridge with Wi-Fi. So you will bridge this. Otherwise, you will be just a layer 3 VLAN interface. So Wi-Fi, I'm going to configure Wi-Fi to be 2 SSID on 2 radio. So same SSIDs on different radio. So they say I'm going to configure guest Wi-Fi on both N radio and AC radio, and we'll map this to assign this to VLAN 10 so that is connected to the same port as port 1. So in this case, you probably want to have another AP connected to somewhere to extend the guest Wi-Fi coverage. They will belong to the same VLAN, and they will be passing through VLAN 10 interface. Staff VLAN is probably more secure, so you are separate from the guest Wi-Fi. And in this case, I'm not assigning to any VLAN, so you'll default into VLAN 1. So you'll go to ETH1 to go out. Let's configure this together. By the way, I just got this box this morning, 10 minutes before we start the session. So everything's fresh. You could have problem, and if it does, then it's good. So we can troubleshoot this together. If it doesn't have problem, it's also good. That gives you more confidence. Interface VLAN, question mark, there's only 2 radio, 0 and 1. Because 0 is N and 1 is AC. And question mark to say what are the options. You can configure a channel, you can have frequency, or you can just set it to be auto. You can have country, and you can set power. Those are the basic stuff, okay? So you don't change any of the setting. By default, there's a channel is auto, country is 00. But in this case, I will set it to be SG. Then you set a SSID. Guest Wi-Fi. Okay, the SSID and just a SSID name. Okay, so you can see what are the options under the SSID. You can be broadcast, non-broadcast. You can set encryption. You can be non or WPA or mix. You can add like .1x later on. Okay, if there's a need. It does support .1x authentication for using external radius server for authentication. For now, we just have the pre-shared key. But for the guest Wi-Fi, I'm just going to be none. So that means it's an open SSID. And I will assign this to VLAN 10 to be the same as port 1. So once you have done that, then we will just do an enable. Because each time when you do something, there's a lot of text. So that's why I don't like to use console. Basically, I have enabled guest Wi-Fi on N radio. And if you show interface Wi-Fi, you will see the guest Wi-Fi is enabled on ATH0. Okay, remember ATH0 is this N radio. Okay, and also if you show interface bridge, is bridged to VLAN 10. This radio interface has to be included into VLAN 10. Okay, then you will work. That means the user connecting to the Wi-Fi and user connecting through VLAN 10, they're in the same network. So if you want to verify through the UI, there was the switch that we configure 21, 22, and tagged with port 3. If you want to verify with Wi-Fi, and it is there, okay? But don't try to click or edit anything from the Wi-Fi, because whatever you change from the Wi-Fi will not be synced to the command line. Okay, but whatever you set on the command line will be reflected on the Wi-Fi. So I will add in the staff Wi-Fi. The staff Wi-Fi, I'm not assigning any access network, so you will default into VLAN 1, which is BR ETH1. Okay, so I set up pre-share key. So now if you do interface Wi-Fi, okay, it take a while. I can see 2 SSID now, 2 radio. I mean, it's the same radio, but it's have another subset of it. It's like a sub interface of ETH0. So the other SSID is staff and guest. So both are connected to this one. So I'm going to now configure, and also again, if you show now BR ETH1, so you'll see the other radio interface is on the other bridge. So they are in separate network. Okay, one is in BR10, another is BR1. Okay, so I will do the same now. And again, if you want to verify from the UI, it's all configured on the end radio. And one has encryption, which is using WPA. So I'm just going to paste this. Okay, that's another beauty of using command lines. Once you're familiar with the syntax, you just paste everything. So you take a while to reset the interface because there's a lot of backend processing. So I see 2 SSID now. I see staff Wi-Fi. I see guest Wi-Fi. So I'm connected to guest Wi-Fi already, as you can see here. So I'm just going to do a speed test. Okay, so I'm connecting to the guest Wi-Fi. So if you show interface Wi-Fi, you have ATH0. This is for the N radio, and this is the AC radio for the guest and stuff. And again, if you want to show, so now there's 2 radio interface on ETH1, which is the stuff for the AC and stuff for the N radio. Okay, similarly, if you do the VLAN 10 bridge, and you can see the ATH0 and 1, which is for the guest Wi-Fi to be in the VLAN 10. It's very clear, right? So the LTE, all you need to do is just to add the LTE interface and set a modem USB port number, because essentially this is attached to, because we are using the USB connection on the mainboard. Okay, it's not a dongle, we're using the USB connection on the mainboard. So it still has a port. But the module is a dedicated module that is attached to a daughter card if you had opened the box before. Then whether it's LT0 or LT1 attached to its respective USB port number. There's some legacy reason. There's some batch use the Huawei LT module. Some we use the QTEL LT module. So the Huawei for LT0 is USB 0, and for LT1 interface is USB 5. Okay, QTEL is another number. Okay, so just bear in mind with that. And the APN is optional. Most of the time when you configure LT interface, it's the simplest thing to configure. You really just need to have the APN. It's optional most of the time, unless the service provider restricts that. But the key one is really the modem USB port number that you use. Like I said, I just get this box this morning. I haven't opened up. I don't know if it's QTEL or Huawei modules. So I will just try this one. Bear in mind, after you configure this, the interface just now when I put up the box, I didn't configure any LTE at all. So we will need to reboot the box to redetect that interface, the LTE. So we will reboot the box. How much can we make a switch interface? You can configure any switch port to be a trunk port, like this one. You don't have to be port 2 or port 1. It can be, depends on your requirements. You can trunk as many VLAN to a switch port, as many as possible, but practically you won't have too much. Again, this is not for organization with thousands of users, it's more for outlet. So the LTE module, yes, you will drop to be honest, 2G, I'm not sure, but 3G, yes. For UI, the HSA, the local UI, like I said, you will be removed soon. We will not have this UI. So we actually don't want you to use the UI now, because we will have UI on the orchestrator later. So you don't need to use a local UI. So the command line is more for advanced engineers, especially for troubleshooting, and also for you to learn now or to understand the concepts and fundamentals, because UI will be just simplified to a lot of us. Okay, so we will move on to talk about firewall rule configuration. HSA is a stateful firewall by default. We also support integration with Menlo and DNS, safe DNS. A few main types of firewall rules. The input rule is really for access to the device service. Okay, that means it permits or denies access to the device service, for example, SSH, okay, or VRRP or IPsec. That means those services will terminate on this box itself. Access rule is for traffic to pass through the box. That means it's mostly user traffic. That means you're going to go in and out. Okay. A DNet rule is for destination net. That means changing when an IP packet comes in, we will change the destination header of the IP packet. So for example, this is a DNet rule. When an IP packet comes into the firewall, you have many headers, right? Two of the main headers, one is the source, another is the destination. Okay, so when the traffic leaves the box, leaves the firewall, the source, the destination is changed to something else. The source is intact. The destination is changed to something else, some other IP. This is more for port forwarding or for you to open internal devices or hosts to the internet. When the public host, when they try to access to internal host, they will be using this red IP address, which is largely your device internet outside public IP. So when they reach the box, hit the DNet rule, you translate the destination to the actual internal device private IP address so that you can route to the internal device. So the DNet rule, again, is more for inbound access, for public to come into your network. When you enable port forwarding or when you enable static one-to-one NAT. For example, you have CCTV or maybe you have video conferencing equipment or whatever device that you want to access to internal device. Source NAT is reverse. That means it's more for traffic to go out. When the user go out to a destination, the destination IP is not changed. When the packet leaves the outside interface, the source is changed to something else, which is the public IP of the firewall. So that when the remote end receives this request, when he returns, his destination can be your public IP. Otherwise, your private IP, he would not know where to route. This concept applies to all firewalls, same for HSA as well. That's the fundamental understanding. Okay, once we have the understanding, then we can proceed to the actual syntax. Again, if you're not familiar, you can always use question mark to configure that. Okay, this is a syntax of configuring input rule. So that means you're allowing someone to access your local service, TCP, destination port number 22, from this source IP. So if you have the orchestrator later, it will be very easy. For example, you have the firewall rules, you can configure input rules, you can add a new rule to permit inbound access, give a rule number, permit a direction from or any inbound interface. You can say the protocol source and destination port number. For now, I highly recommend you to understand the command line. Outbound access is basically permit anything that goes out of something. Okay, you can be ETH0 or LT0 or 1. Okay, so this is by default there so that you can go out to the internet with a default rule. Source NAT, that means port address translation or PAT. That means hide all your internal. So when the user goes out, your source will be netted to the IP of the exit interface. Port forwarding is DNet rule. That means for inbound access. For inbound access, each access always come with a pair. This is very important. Always come with a pair. One is do the translation. That means DNet is just do address translation only. This is a dynamic port forwarding. That means anything that comes into the ETH, comes into anywhere, it doesn't matter. You have destination port number 8080 using TCP. I will translate to an internal IP 1.12 and for this port number. So this is very powerful so that your WAN IP can be any dynamic IP, DNS or whatever, or it's not something that you know of, or you don't have to remember that. When the request comes in with a TCP D port number 8080, the firewall will resolve to will translate to the internal IP with this port number. So that saves your trouble to have a static IP or remember what is the static IP for the WAN. Then this is only doing translation only. The other one is the access, because you still have to allow it to pass through. You say permit all, and that means from all interface, or you can have a permit inbound interface. So the syntax, again, can use question mark to inbound, or if you have inbound, then you have to put the interface name. or you can just save the trouble to say, or it's all about your policy. You want to be less restrictive or more restrictive. Then you can specify the protocol and port number and all that. Again, if anything not sure, just question mark. As you can see, always come with a pair. One does translation, another allows access. So this is very important. Okay. So one-to-one is basically one IP to one IP. Anyone that is coming to default TCP 443 to this IP, that means this IP has to be publicly known IP because you want to do one-to-one NAT. Okay, so in this case, you have to configure this IP on your WAN interface so that the outside world knows how to reach to this static IP. Then you will do a one-to-one translation to your internal IP. That means translate this to this. Okay. And again, you still have the access rule. You can permit all to your internal IP, or you can restrict to the particular port number. So it's highly recommended to be more specific for security. After you configure the firewall rule, again, it's always good habit to show to verify that, because the show tells you the actual operating status of the rule that has been configured. And also when you show input list, there's a keyword, question mark. If you have the all, that shows all the default rules. The default rules shows the default service that is been open to outside, so that you don't have to explicitly configure firewall rules to permit this access. So for example, like this AT is more for web service, which will be removed later. So these three rules are for IPsec, okay, ESP and UDP IKE 500. Then ICMP is permitted, and some other like OSPF multicast and VRRP and DHCP and DNS. So the top rule is basically the stateful rule. That means anything that comes in that is related or established, that means it's a part of our existing session. That means it was there. It is part of the existing connection. You will automatically permit. So you don't have to open rules to permit it. For example, if you configure access list on a Cisco router, you have to permit the return traffic too. That's a bigger problem. That's why it's not stateful. In the newer version of iOS, you can enable stateful, but that will have a huge performance impact. So if you just purely use access list, it's just you have to open outbound and you have to open inbound as well for the return traffic to come back to the user. So if you do the stateful inspection, you have a rule to say you will track the packet headers, because for the return traffic, the packet header will have to indicate this existing session. For example, is a TCP ACK. Let's say, okay, it's an existing session. When a new session goes out, it's a sync, TCP sync. And when it is being permitted, you will create a session table for that connection. So when it is an ACK to an existing connection, it will be automatically permitted. Okay, so that's how stateful firewall works. So similarly for access list, you say, oh, you will permit the existing session. That means a return traffic for the existing session. You will be automatically permitted. You don't have to explicitly open a firewall rule to allow to permit the return traffic, unlike Cisco iOS access list. All you need to do is really allow outbound access. Or if you are going to allow inbound access, it has to be very specific to that destination only for that particular port number. For example, when you do TCP port. For static NAT, yes. Unless you're NAT, yes. You have to announce this IP. It has to be reachable to the public internet so that they know how to come into you. And you have to be dedicated. That means anything to this IP is translated. That's a static one-to-one NAT. So the VRRP basically provides device redundancy. So on the LAN side, you will basically have a virtual interface. Two boxes will appear to have a one virtual interface, which is the default gateway for the user to go out. If the active box fail, then the standby box will take over the virtual interface so that the failover is transparent to the user. You can also do load sharing. So for example, you have two VLAN. You can have VRP active on VLAN 21 and standby on 21 on the other box. Likewise for another VLAN active and standby here, so that this box will become active for VLAN 21 during normal operation and become a backup for VLAN 22. So similarly, this will become active for 22 and backup for 21. So that provides the redundancy and load sharing if you want to be active. But most of the time, you can just be completely active and the other box just be standby to simplify your configuration. The other scenario we'll talk about is the captive portal HotSpot configuration. So we will have a cloud HSG. So all you need to do is really apply the standard set of configuration. Use this command to change this IP to point to your own HSG IP. Because what this command says is anything goes to this URL will be redirected to this IP. So in our standard template config, we have this as a URL already. So you don't need to change anything. All you need to change is to point this IP to your own HSC IP, and that's it. So the multi-WAN, we have a very detailed explanation on how multi-WAN links works. There's a lot of people call multi-WAN bonding, load balancing, or link balancing is pretty much the same thing. Okay. So what you do is you have multiple links, uplinks. You can set priority or metric. If they have the same metric, then you are expecting to forward traffic onto each link, which is called link balancing. If you do balancing, you have each link, you can have different speed. Then we call it weight. Let's say if it's 10, 20, 30. So the box will allocate different amount of traffic across each link so that you can fully utilize all the bandwidth available from all the links. So let's say 10, 20, 30, you can have a total of 60 throughput. Then if any of the link fail, then whatever traffic that goes on this link will be automatically transferred to the other two remaining alive link. Okay, so that's how balancing and failover works. You can also do active standby. That means if this link has higher throughput or better performance, you just be a lower metric. So you become active. And this one, higher metric, become a standby only. So that means only if this one fail, the traffic will come here. So it is that simple. Okay, you can apply multi-WAN to physical interface, or you can apply multi-WAN to VPN tunneling. So then when you do VPN tunneling, you're expecting to load balance between the VPN. So that's what they call it, VPN bonded. Okay. For this version, by default, we are tracking the tunnel availability based on pin packet loss. This after how many pin you will be declared as this link down, your failover. In future version, which will be released soon, will be based on latency and jitter. So that means if the link is up, but latency is too big, it takes too long for a round trip, too much packet loss. So we have explained the QoS, how it works. You can allocate bandwidth for different VLAN or different network. You can also classify traffic based on applications. Then you can limit group of applications, allocate bandwidth, and prioritize them. You can also limit per user based on per user bandwidth, based on user profile when HotSpot is enabled. So now we're going to do a demo to do read limiting. Read limiting is basically to cap per host speed. So that means you set a maximum speed per connection or per host. You can also go by IP based. For example, like this case, you can set the entire subnet. That means all the hosts in this subnet will only be limited to 5 meg upload and download. So just bear in mind, read limiting or QoS is not stateful. That means you have to set a rule for both two ways, for upload and download. So now we can try, for example, you can just to read limit upload. But before that, I will just do a demo to show how it looks like when there's no read limiting. So we're just going to do a speed test for a normal connection. So I'm going to connect to the guest Wi-Fi SSID, which we have previously configured. Okay, I'm connected. So I'm just going to run a speed test for when there's no read limiting or when there's no speed control. Practically, we can get as much as possible from the network. And there's no read limiting. So I'm just going to now limit the upload first, just to show the differences. Firewall limit. Okay, so the upload is there. And I'm going to run another speed test. So just bear in mind, I'm limiting the upload. So there's no limit for the download yet. And later we'll try with download. I've set the upload to be 5 meg only. So straight away, I'm capped with the upload. And now I'm just going to add the download rule as well. So as you can see, the upload is relimited and download was not. So now I have two rules. Okay, upload and download. So it's basically upload is for capturing the source. It goes out, and download is for return. Okay. So I'm straight away capped for the download as well. Okay, so this is how read limiting works. Again, read limiting is on a per host basis, or you can also configure to be on a per application. You can set, instead of mapping to the subnet, you can map to the application or by port number, protocol and port number, or you can be on a session based. That means you will capture a particular connection from this source to that destination for that protocol and port number. So it can be extremely granular and specific. So that will limit each connection for each session, the speed control. So it's very granular. And as you can see, the configuration is actually very simple and straightforward. So imagine if you're going to use some other third-party solution, it's going to take a lot of commands to achieve this objective. So the other QS option that we talk about is class-based QS. Class-based QS, basically, there are a few key areas that we need to understand. One is the marking of the traffic. Another is about controlling of the traffic. So by marking the traffic, that means incoming, when a packet goes into the box at the ingress interface, then you will mark the packet. It can be based on IP address or subnet, or you can, because firewall rules, you can configure again by application, protocol, and port number. So once you mark the traffic or packets, then you can queue them based on different class. That means the more priority, higher priority class of traffic, you can put it on the top and the lower on below. And at the same time, you can set speed, minimum and maximum speed for each class of traffic. So the key difference is the class of traffic we're talking about is, for example, we set 50 and 60 is for the entire class of the traffic. That means everybody share the same amount of bandwidth. So it's not on a per host or per session base, it's on a per class base. You can use firewall set rule to be very granular to match what type of application or what group of traffic that you want to prioritize or you want to control or guarantee the bandwidth. So I'm just going to remove the read limiting. In this, for simplicity, I'm just going to mark the traffic by subnets as well. So just to say we get the same results. Again, the class-based QS is we mark the packet on the inbound interface. That means ingress. And we QS control the packet when the traffic exits the outbound interface. So that's why we have to, for two-way bandwidth control, we have to do it on both inbound interface and outbound interface. When we apply on the outbound interface, so that basically limits the traffic to go out. Okay. So when we apply the traffic on the LAN, the local interface, that controls the traffic. When the traffic exits the interface, that means return back to me. So this is basically, in short, this controls upload and this controls download. Okay, so I have marked the traffic. As you can see, you can have different marking, different class of traffic based on your configuration to put them into different queue. So in this one, I'm just going to use one. Okay, I'm just going to apply on the VLAN 10. So once you have done that, you can show interface, traffic group, traffic shape. So this says on the WAN exit interface, we're going to set a maximum 300 MAC. And for this class of traffic, we're going to say you can only have 10 MAC. We will guarantee or 10 MAC, and you'll also be capped to 12 MAC. So we can allow you to burst a little bit when the traffic exit the interface. When we say exit, that means it's upload. For the VLAN 10, that means the traffic exit VLAN 10, that's essentially download 10 and 12. So we're going to do a speed test again. Because I set it to be minimum 10 and maximum 12, so you can be potentially reach to 12, or you can just, you want to cap it to be 10, that means you set both to be 10 MAC. So in this case, it would be both 10 MAC. So as you can see, it works flawlessly for both upload and download. And again, you can try to practice this by configuring firewall set to map to a different color or to mark for different application or different connections. So that gives you a lot of granularity. Or simply, you can just do it on a per host or based on IP address. So the other option is simpler. So you can go by IP only. This option supports IP only. You will just need to apply on the LAN or on the private interface, because we have a virtual interface to simulate ingress and egress. So we don't have to apply on the WAN and LAN. So in this case, you can just apply on the LAN only. So I will just show this as well. First of all, let me remove this to prevent conflicts, just to make sure there's no rules applied. So I'm just going to apply a rule, say, okay, just to see the difference, I'm just going to apply to 2 MAC. Okay, maybe 15. 2 MAC is too little. So this one, maybe I set it to be 50. That means for this interface, upload and download, I set it to be maximum 50. And for this class, I'm going to set it to 20. Allow you to burst a little bit to 22. And everything else that is not matched will be fall into the default, which is 5 MAC only. So I'm just going to apply to traffic shape. This is basically matching by IP or subnet. So we just need to apply on the LAN interface. And now we can do a test. And again, we configure to be 20 and 22. So we should be getting between 20 to 22 for both upload and download. Without this, we can go up as high as the network permits. So this is how it works. Okay, for QS, read limiting on a per flow or per IP host, class-based queuing on a per IP or per subnet or per application. You group them into different class and set into different priority and allocate to different bandwidth. So it's very granular. Depends on your business objectives. Now we go back to do the multi-WAN load balancing. Okay, we didn't show this just now. We quickly configure this. So we just have to assign them to both interfaces that want to participate multi-WAN in the same group. Okay, then you will configure a tracking, the track IP address, let's say whichever IP you feel is reliable. You can optionally set timer, like how quickly to declare this link is done. For example, how many number of failure, how frequent you want to test. You can use default metric 1, interface LTE 1, similarly multi-WAN group 0. I'll just copy this. The reason I'm using a little bit timer is because I want to make it longer, because especially when you're doing speed tests, you are jamming up the LTE link connection. You can have false alarms. It thinks the link is already down because you didn't get the response. So we set it to be higher, the timer. Similarly, metric, we can set it to be 2 because it's a backup. Then we configure the multi-WAN rule. Basically, this says everything, all the traffic going to anywhere the destination is using multi-WAN group 0. So that essentially configures all the traffic to send to multi-WAN 0. Yeah, I will use SSH to manage this, because console will have a lot of message. I will show you when you start the service. Each time when you change the multi-WAN rule, you have to restart the service because you will need to recompile the configurations. So basically, we're tracking 2 ETH 0 and LTE, and all the traffic 100% is on ETH 0 because that's what we intended. So in order to verify this, I will configure. Okay, I'm already connected. So what you can do is you can just do a TCP dump on ETH 0. You will see actually all the traffic is going through ETH 0. Okay, for a speed test. Again, you need to dump on the layer 3 interface. So, okay, we do another speed test just to capture the traffic. So just now we see a lot of traffic on the ETH 0, and we see almost no traffic on LTE 1 because it's a backup interface. Again, this is how you can show to the customer. By the way, we get 300 meg because my office internet is only 300 meg. If it is higher, we get higher. Again, if you verify ETH 0, so this is very convincing using TCP dump to show the traffic. Okay, if you want to do a load balancing, let's say both interface you want to enable to carry traffic, so you will just set it to be the same metric. Okay, then you will stop and start your service. Okay, then you show multi-WAN status, and now you see 50-50 because I didn't set any weight. That means by default he's treating both are having the same weight. But anyway, we just want to see this traffic going through the LTE 0 now. So we do a speed test again. Okay, so the traffic now is going across the LTE as well. Okay, I just want to make sure I'm connecting to the guest SSID. That means it's really going through the box. Okay, so they are load balancing, okay, going through both interface. I'll set it back. I don't want it to consume my SIM card quota. Okay, we'll move on to the rest of the lab. We're going to just apply this to VLAN 21 and use VLAN 21 and 22 to do the lab. 21, 22. So rightfully, if I have 2 boxes with the same configuration, and I should be having virtual IP on this interface, having virtual IP on the other box because I set lower priority. So if the other box want to be active, I set higher priority to be 120, but in this case, I only have one box. Both of my interface will be active. So this is how you see whether the VRP is active. If it's active on my box, you will automatically create a VLAN interface, okay? But because I didn't change my interface IP address, so rightfully I need to remove that physical interface. So that it doesn't conflict with the virtual interface. The physical interface has to be different from the virtual interface. So which means in each segment, you will need to have 3 IP for the gateway, 2 for the physical IP, 1 for the virtual IP. Okay, so because there's no other box, so I'm still active, even for VLAN 22. So I will skip to this one. We already talked. I will just apply the config and quickly paste. Okay, so the hotspot is enabled. So I'm just going off and on my Wi-Fi. The captive portal will come up. You can do a lot of interesting stuff with the captive portal, like we said, which is our strength, by the way, customizing of the portal and advertising. So everything, as you can see, you can ask user to log in, or you can flash advertisement, and then system tracks the logged in users. So default, there's a user binded to that device. And you can also apply bandwidth control on the user from a radius side and everything. So before I final wrap up, as we go along to do the configuration changes, the changes are automatically tracked on the mFusion. So today we did a lot of hard work on command line, but in future release, you don't have to do all this. But each change, the good thing is the mFusion tracks each configuration change between different versions. Okay, so there was to change from the default. Okay, so if you change from the last config, we just added to the multi-WAN, and also the latest config, which is the Wi-Fi hotspot, is not uploaded yet. Every 10 minutes, you will auto check any config change and auto upload it. That's all for this.